Couples were recruited for a study of how many words people speak in a day. A random sample of 52 males resulted in a mean of 16,073 words and a standard deviation of 7,772 words. Use a 0.05 significance level to test the claim that males have a standard deviation that is greater than the standard deviation of 7,460 words for females. Use the accompanying method approximation to estimate the critical value of the chi-square for this scenario. How close is it to the critical value of the chi-square equals 68.669 obtained by using StatDisk and Minitab? So you want to click on this icon to view the information about the approximation. So when you click on that, you're going to use the following. You're going to use this formula, and then you're going to use the following for K. So I copied this into my workpad. Okay, so here's the question. Okay, and so it says here, for large numbers of degrees of freedom, we can approximate critical values of chi-square as follows. We have chi-square, which is equal to 1/2 times z plus the square root of 2k minus 1 squared. So here we say that k is the number of degrees of freedom and z is the critical value found from technology or from a standard normal distribution table. Now in this scenario, we have the degrees of freedom is equal to 51 because the sample size up here is 52. So a chi-square distribution table does not list an exact critical value. So if we want to approximate a critical value of chi-squared in the right tail hypothesis test, alpha is going to equal 0.05 and a sample size of 52. So what we're going to do is we're going to do the following. We're going to let K represent 51, which is the degrees of freedom. We have the value of Z, which is going to be equal to 1.64. Now, a more accurate value of Z would be found from technology. So let's go back to that display again. So this is what your display is going to read, and it's going to give you the following information. And then we're going to plug these values into our formula to find the approximation of this critical value. So let's go back here. So we're looking at this formula, and then what we're going to do is the following. Okay, we're going to let Z represent our value of Z there, which is 1.64. So we have 1/2 times 1.64 plus 2 times the value of K, which is 51, and then minus 1. So what we're going to do is now we're going to evaluate this expression. So the first thing we're going to do is the following. We're going to take 2 and multiply that by 51. So 2 times 51 is 102, and then we're going to subtract the 1. Okay, so we subtract the 1, and we get 101. So now we have 101, and we want to take the square root of 101. So I'm going to go second square root of 101, and then press enter. And now I want to add this number of 1.64. So I'm going to add plus 1.64. And then that gives me this following number, 11.68987562. So now I'm going to follow again the order of operations. So now I want to square that number. So I'm going to go ahead and just hit square because it's going to square this number here. And then I'm going to press enter. And it gives me this value here, which is 136.65319237. And then I'm going to multiply it by 1/2. So I want to hit times. I'm going to take the answer. I'm going to multiply it by 0.5 or 1/2. And it gives me the following. It gives me 68.32659619, which gives me the value of 68.33, rounding it to 2 decimal places. So now that we found the approximation, we want to compare the approximation, okay, the chi-square approximation with the given value chi-square from the problem. because the chi-square, we want to know how close is it to this critical value, which is 68.669. So in order for us to compare, all we're going to do is just subtract these two values. We're going to take 68.669 and then we're going to subtract 68.33. When we subtract those two values, we get 0.339. So based on the accompanying method of approximation, the critical value of chi-square for this scenario, which is the approximation, is 68.33. So we would say that this estimate is close to, within 2 of, because this value right here is within 2 of that critical value. And that's of the critical value of the chi-square of 68.669. So let's go ahead and put our answer in. Okay, so here we got the approximation to be 68.33, and we're going to say that the estimate is close to within 2 of that critical value. Check our answer, and there is our result.